writing radicals in the simplest form with, so like square root of x cubed, solving for square root of x cubed, or square root of x to the fourth y to the fifth.
Okay, let's start with square root of x cubed. I can write that as the square root of x squared times the square root of x, correct?
Mm-hmm.
What's the square root of x squared?
X.
So that's the answer.
Okay.
Okay. And then you said the square root of x to the fourth, y to the fifth.
Mm-hmm.
How many x's will come out of that?
X squared.
Right? How many y's will come out of it?
Y squared.
Leaving
Remainder y.
Square root
y.
Square root of y. Perhaps the best way to do all of these is to use fractional exponents. For example, if I do this, now you multiply exponents, right?
Mm-hmm.
So you immediately get this, and then that's equal to x squared times y squared times y to the 1/2, and that's
equals square root y.
Squared y squared square root of y, exactly. But when you're dealing with numbers bigger than 2 or 3, then this really is probably the way to go. And
Okay.
as you go into calculus and precalculus, you're going to find more and more that fractional exponents make more sense than radical signs. When you get to calculus, you start everything with the exponent. So having it in this format here, boy, you start, if I were to take the derivative of that, I start with 1/2. 1/2 times x to the fourth, y to the fifth to the minus 1/2. In other words, the exponent is critical, and radical signs generally need to all be converted to fractional exponents. What else you got?
That's pretty much all we've been working on is that, so
Okay.
the problem would be
Let's talk about your ACT, SAT. You're a junior, right?
yeah.
When are you taking your next test?
I guess they're bringing in like a professional company to do another practice SAT, and I'm not sure when that's going to be.
So it's SAT?
Yeah, they switched from ACT to SAT.
Boy, everybody has done that. It's because, you know why? It's because the SAT changed its format in 2016 to be much more like the ACT. They now include some trig, and they include a little pre-cal or conic sections. The only differences that used to be between the ACT and the SAT are no longer there. So I've noticed that all my students in Colorado are switching to ACE or SAT. Well, why don't we finish our session with a few SAT? When are you going to take it? Do you know?
I think in April.
Okay. Well, it's never too soon to start preparing. Now, hold on a minute. I don't want to go to here. How many times have we done SAT from this one right here?
None.
None?
Yeah.
Okay, good. I will keep a notepad as to how far we get. And whenever we have a session and you don't have anything to cover, we can cover SAT. Now,
All right.
the one thing that SAT does that ACT did not do, and that is give you all of these general formulas. Notice
Okay.
area and circumference of a circle, area of a rectangle, triangle, Pythagorean theorem, these two special right triangles, and then volume stuff.
Mm-hmm.
So you don't have to really worry about memorizing these, although I would still suggest you do so, just because
Okay.
these are so common that you want to know them. This one, incidentally, is the one that's put out by the college boards. The people that make the SAT,
Mm-hmm.
this is their practice test.
Okay.
As opposed to if you went down to the library, you might find 6 different books by McGraw-Hill, Kaplan, Callis, all these different publishers that
Mm-hmm.
publish SAT practice tests, but they're all different in a little bit, in a little ways, subtle ways. And so the one I trust the most is the college readiness, college board people. And that's what this is.
Okay.
They start out easy and they get harder. So can you read that okay? I can blow it up a little.
Yeah,
All
I
right.
can read it.
Okay.
Number 1 is D.
Okay. If
Um,
you get it right, I won't say anything. I mean, if it's clear, you know what it is.
Second, I need a pen here
No, you don't.
for.
You're adding these.
Oh, you're adding them. Oh,
The
okay. So
real parts, add the imaginary parts. What do you get?
okay. It's D.
Let's
Oh no. What am I talking about? It's B.
look at it again. What's 3i plus 9i?
12I. So A.
Okay. The real parts are minus 1, which would be A or B.
Mm-hmm.
Yeah, whenever you're adding or subtracting complex numbers, it doesn't really matter that I equals square root of negative 1. You're just adding the real parts and you're adding the imaginary parts. Multiplying is a different story. How about number 3?
4M plus 5P.
Say again?
Isn't it 4M plus 5P? D.
No, but you're close. Armand sent
Oh, okay.
Texas
Armin's an M,
5
so
out.
it's not in 4P. Okay.
5m plus 4p. Be careful of answering too quickly. In other words, these are definitely timed. You're only going to average about 1 minute per problem. In other words, they're going to expect you to do 60 problems in 60 minutes. So the faster you can do them, the better. But don't make a silly mistake like that.
Mm-hmm.
Number 4.
B.
Yeah. Good. Number 5, and you may or may not need a piece of paper for this. You should have a piece of paper in front of you, regardless.
Yeah, I have one.
Okay.
It's C.
How many total xy squared terms are there? Remember that negative sign has to be distributed every term that is in the parentheses on the right.
Yeah, that would make the 3xy squared negative, and you have a 5xy squared on the right,
Excuse me.
on the left side.
Thank you. I was doing it wrong.
No, you're good.
My apologies. Number 6.
A.
Yeah. Notice what they're asking for is slope.
The rate of change.
Yeah, exactly. The rate of change, which is slope. And remember that, because that's what the reason they spend so much time in math teaching you about slope is because eventually when you get to calculus, it's all about slope. And as you say, slope is the rate of change. Only with calculus, it's the instantaneous rate of change, which is a lot more difficult to calculate if you think about it. Rate of change is rise over run, and instantaneous would be 0 divided by 0. Well, that's why it needs calculus. Okay, how about number 7? Let me give you a hint. Number 7's a really easy problem.
Is it A?
No. Remember, we're solving for P. So we're going to multiply both sides by the denominator and divide both sides by the numerator.
So it's B.
Yeah.
Okay.
Okay. And look at all of the information they give you in that paragraph. Who gives what P means, R means, N means? None of that matters. Basically, what you're doing is solving an equation that looks like this. Hold on. Sorry. You have an equation that is M equals A times B divided by C times P. That's what you're doing. And when I solve for P, I multiply both sides by C, and I divide both sides by A times B. So the fact that my A, B, and C are these, ridiculously complicated things doesn't matter. I'm still going to solve it in the way I would solve an algebraic equation. This is kind of a great example of, you don't need to use substitution here, but you could. You could let A equal to this thing on the left, B equal to that thing on the right, and C equal to the whole bottom thing. Notice that each one is more complicated than the other. And then to further confuse you, they give you all of this information that's completely irrelevant. So take note of that. Just because they give you all of this information doesn't mean you need to use it. A lot of people could spend 5 minutes on this problem going in the wrong direction, which would be to try to multiply everything together and then try to divide it by that. My God, a person could spend 15 minutes trying to do that. And the only reason you would ever do that is if you forgot to look at the answers. In other words, if you look at the answers before you try to answer the question, that tells you which direction you need to go. In other words, you can tell that you don't need to do any of this multiplication or division here. Because all you need to do is solve it like this problem on the right. Number 8. If A over B is 2, what's B over A?
4.
No. What's the reciprocal of 2?
1/2.
Okay. And now what's 4 times that?
2.
The answer is C.
Okay.
You see what I'm saying? In other words,
Yeah.
A over B.
Oh, I thought it was
2.
4A over. Okay.
Well, it is 4B over A, but the first thing I want to know is what is B over A?
Oh, I thought it said 4A over B.
Ah, well, that would just be 8. And that answer isn't on there. So if you made that mistake, you would quickly realize that you had made a mistake because the answer you came up with is not one of the multiple choices. And that's about the only advantage of multiple choices, is that if you happen to make a mistake and your incorrect result isn't on there, then it's a giant red flag that you made a mistake, and go back and rethink the problem.
Okay.
Okay. Number 9. First of all, how are you going to solve number 9? Are you going to use...
solve by elimination.
Okay, good. Which means we need to write it how? I need to write the first equation like this in standard format. How should I write the second equation?
Multiplied by 4. So
hold on. Notice that the y and the x are in different positions.
Oh, okay. So rewrite it to negative x plus 2y.
Okay. That's the first big step. Now what would you do?
Multiply the bottom equation by 3.
Okay. So this was equation 1. That was equation 2. What's our new equation 2 look like?
Negative 3x plus 6y equals negative 57.
And then I actually usually cross that off so it doesn't get in my way. Now add them.
So you'd get 10y equals negative 80. Divide by 10 and you have y equals negative 8.
And notice that because it's multiple choice, that tells you what the answer is, and you don't actually have to solve for x. Typically, you know, if this was a math class, you'd have to solve for x and y. But because it's multiple choice, you can speed it up by not worrying about solving for x. And you could have also taken the path of solving for y on this. In other words, I could have multiplied equation 2 by minus 2, and that would have eliminated y and solved for x. And since there's 4 different values of x, that would have been just as valuable to do it that way.
Ten would be A.
I'm sorry, what?
10 would be A.
G of 4 equals 8. So
G of negative 4, it would be the same thing because it's a quadratic.
hold on. So let's work with G of 4. G of 4 is A times, okay, so you're right, plus 24. So, and they tell us that G of 4 is 8. So now I have 8 equals 16A plus 24. 16A equals minus 16. A equals minus 1. So what's the value of G of minus 4?
Negative 1?
Yeah. In other words,
What?
your logic was correct, but well, hold on a minute.
That shouldn't make any, that should be 8. But
You're correct. You're absolutely correct. What did I do wrong here? Let's see. G of 4 is going to be A times 4 squared plus 24. That allows me to solve for A. G of 4 is 8. So 16A equals minus 16. So A is minus 1, but that's not what they're asking for. They're asking for G of minus 4. You're absolutely correct in the way you did it and the speed with which you did it. I did it the slow way and gave myself the chance of making a mistake. You did it the fast way, knowing that G of minus 4 had to be the same as G of 4. Very good. Number 11. Hold on, let me expand it a little bit. How are we going to solve 11? Tell me the equation I need to write.
You can set them equal to each other.
Yeah, exactly.
So 1.75 plus 0.4x equals 2.35 plus 0.25x.
Go ahead and solve that.
1 second, just moving the control panel for the good meeting.
Which side are you going to move variables to?
Move the variables to the left and the so you did 15x equals, okay.
What did I do wrong here? Oh. No, what did I do wrong? Doesn't 0.15 go into 6 4 times?
Yeah, it does. Oh, it's 0.6. It's 0.6, and still it does it.
It still goes in 4 times. I get 4. Notice. What we failed to do was read the entire problem. What was the price per pound of beef, which is C? So we did solve for X,
So
But
we need to plug it back into C.
so C is $1.75 plus 0.4 times 4, which is
So it's 0.16.
1.6. Yeah, so that's 3.35. Ah,
So D. Okay, that's clever.
it get very tricky on you. But the nice thing is that when they get tricky, they don't put the fake answer. In other words, if they'd have really wanted to make this problem tough, they'd have put 4 on there, right?
Yeah.
Because if they'd have put 4 on there,
You would have immediately gone to 4.
immediately answered 4 and gone to the next problem. The fact that it was actually trickier than that, but they give you a heads up by not putting 4 on there. And that's pretty common also. In other words, it just reinforces the problem that if you come up with an answer that is not one of your multiple choices, then you need to rethink the way you're doing the problem. A lot of times rethinking it is merely rereading it. What were they asking for? They weren't asking for X. They were asking for C. All right, so we got through 11. I'm going to make a note that we got through 11, and we'll know where to start next time we have a day where we want to work on SAT.
All right, sounds good.
All right? All right, Cole, I'll talk to you next Monday. Have a good week.
You too.
Bye-bye.
Bye-bye.